The future was meant to be electric, and Tesla's dominance seemed inevitable. The relationship between Tesla and Toyota was strong, with Toyota being a major shareholder. Elon Musk's vision of an all-electric world appeared unstoppable. But in late 2024, something changed. After a secret meeting at Toyota's headquarters in Japan, Elon Musk was visibly shaken. What he saw that day would challenge everything we thought we knew about the future of transportation. Let's dive into this new chapter. The rise of an empire. Elon Musk thought he had already won. Tesla's stock was soaring, legacy automakers were scrambling to catch up, and the future seemed purely electric. But while the world was focused on the EV revolution, Toyota, the world's largest automaker, was quietly working on something that would change everything. This wasn't just another hybrid system or a minor improvement. Elon Musk himself has stated that this engine could destroy the entire EV industry. But before we get into that, we need to understand how we got here. A legacy of innovation. The story of Toyota begins nearly a century ago in a small textile company in Japan, where a family's dedication to innovation laid the foundation for one of the greatest advancements in automotive technology. Sakichi Toyoda, an ingenious inventor, revolutionized the textile industry with his creation of the automatic loom. This invention not only automated the weaving process, but also introduced the concept of jidoka, automation with a human touch. This meant machines could halt automatically when a problem occurred, ensuring consistent quality and efficiency. This principle would become a cornerstone of Toyota's manufacturing philosophy. Building on his father's legacy, Kiichiro Toyota ventured into the automotive industry. He saw inefficiencies in American mass production and imagined a more streamlined approach. Kiichiro developed the just-in-time JIT production method, which emphasized producing only what was needed, when it was needed, and in the exact quantity required. This minimized waste and optimized efficiency, laying the groundwork for what would become the Toyota Production System, TPS. The TPS is built on two key pillars, JIT and jidoka. JIT focuses on synchronizing production processes to ensure a continuous flow and reduce waste, while jidoka emphasizes quality control by empowering both workers and machines to detect and resolve issues immediately. This dual approach not only boosted productivity, but also ensured quality at every step of the manufacturing process. Toyota's commitment to continuous improvement, known as Kaizen, further set it apart from its competitors. This philosophy encouraged everyone, from assembly line workers to executives, to actively seek out and implement improvements in their work. By fostering a culture where suggestions for enhancement were valued and acted upon, Toyota cultivated an environment of perpetual innovation. Adaptation to change. Toyota's ability to predict and adapt to market trends became clear during the 1973 oil crisis. As fuel prices soared, consumers sought more fuel-efficient vehicles. Toyota was ready, offering cars like the Corolla, which provided exceptional fuel economy at a time when many American manufacturers were struggling with a decline in demand for their larger, less efficient vehicles. This foresight and agility solidified Toyota's reputation as a responsive and forward-thinking automaker. In the early 2000s, Toyota once again showed its innovative strength with the Prius, the world's first mass-produced hybrid vehicle. By combining a gasoline engine with an electric motor, the Prius delivered impressive fuel efficiency and lower emissions, appealing to environmentally conscious consumers. This move not only set a new standard for automotive technology, but also cemented Toyota's role as a pioneer in sustainable mobility solutions. Through unwavering dedication to efficiency, quality, and innovation, Toyota transformed from a small loom manufacturer into a global automotive powerhouse. The principles established by Sakichi and Kiichiro Toyota continue to guide the company today, ensuring it remains at the forefront of the automotive industry. The legacy of the internal combustion engine. But there's more to this story than just innovation in electric vehicles. The internal combustion engine, ICE, has been a cornerstone of technological progress for over a century. It's powered the vehicles that shaped modern society, and its evolution has been marked by continuous improvements in efficiency, power, and reliability. The journey of the internal combustion engine began in the late 18th and early 19th centuries. In 1791, John Barber developed a gas turbine, and by 1794, Thomas Mead patented a gas engine. That same year, Robert Street built the first engine to use liquid fuel. These early inventions laid the foundation for future developments in internal combustion engine technology. This combination of Toyota's long-standing history of innovation and the continuing development of the internal combustion engine sets the stage for a future that might not be as electric as we once thought. In 1707, French engineers for the first time successfully ran a prototype internal combustion engine, the Parola 4, which powered a boat on the Sun River in France. Following this, Swiss engineer François-Isaac de Raza created a hydrogen-powered internal combustion engine, which he fitted to a primitive vehicle, marking one of the earliest examples of a combustion-powered automobile. A major milestone came in 1876 when Nicholas Otto, working alongside Gottlieb Daimler and Wilhelm Maybach, developed the compressed charge four-stroke cycle engine. This design, known as the Otto cycle, laid the foundation for most modern internal combustion engines. The four-stroke process, intake, compression, power, and exhaust, allowed for more efficient fuel combustion and better power generation. Toyota's journey with internal combustion engines is marked by a continuous commitment to innovation and quality. The company's engines have built a strong reputation for durability and performance. One standout example is the 2JZ engine introduced in the early 1990s. This 3.0-liter inline-six engine, featured in models like the Toyota Supra, became legendary among automotive enthusiasts. Its sturdy build allowed it to handle significant power upgrades, making it a favorite among tuners and racers. When it comes to technological advancements, Toyota has been a leader. In 1995, the company introduced variable valve timing with intelligence, VVTi, which marked a major leap forward in engine efficiency and performance. This system optimizes the timing of intake and exhaust valves, boosting power while improving fuel efficiency. Building on this, Toyota developed dual VVTi, which adjusted the timing on both the intake and exhaust camshafts, refining engine performance even further. In 2007, Toyota launched the Valvematic system, which offered continuous adjustments to valve lift and timing. This innovation improved fuel efficiency by controlling the air-fuel intake through valve control, rather than relying on a conventional throttle plate. The result was a more responsive engine with reduced emissions. As environmental concerns grew, the automotive industry faced mounting pressure to reduce emissions and improve fuel efficiency. Toyota responded by developing lean burn engines that operate with a higher air-to-fuel ratio than traditional engines. In 1984, Toyota became the first automaker in the world to mass-produce lean burn engines. These engines offered better fuel efficiency and reduced emissions, aligning with global efforts to combat environmental degradation. In 1997, Toyota revolutionized the automotive world with the introduction of the Prius, the first mass-produced hybrid vehicle. The hybrid synergy drive system combined a gasoline engine with an electric motor, allowing the vehicle to run on either or both power sources. This innovation led to exceptional fuel efficiency and lower emissions, setting a new standard for environmentally conscious driving. Toyota's dedication to refining the internal combustion engine continues, and the company has developed more compact and efficient engines capable of running on various fuels, including gasoline, synthetic fuels, biodiesel, and hydrogen. These engines are designed to meet stringent environmental standards and can be used in a variety of vehicle types, including hybrids and biofuel cars. Enter Elon Musk. In 2008, while Toyota was refining its hybrid technology, a new player emerged on the automotive scene: Tesla Motors. Under Elon Musk's leadership, Tesla's vision was clear: electric vehicles were the future. Tesla's journey, marked by innovation and ambition, would soon challenge traditional automakers and reshape the automotive landscape. Tesla Motors was actually founded in 2003 by engineers Martin Eberhard and Mark Tarpenning, with the goal of producing high-performance electric sports cars. In 2004, Elon Musk led Tesla's initial funding round, investing $6.5 million and becoming the company's chairman. Musk took an active role in product design and strategy, pushing the company toward ambitious goals. In 2008, Tesla introduced its first vehicle, the Roadster, a sports car capable of accelerating from 0 to 60 miles per hour in under 4 seconds, with a range of over 200 miles on a single charge. The Roadster shattered preconceived notions about electric cars, proving that EVs could be both high-performing and desirable. Building on the success of the Roadster, Tesla launched the Model S sedan in 2012. The Model S received widespread acclaim for its performance, safety features, and sleek design. It became the first electric car to top monthly sales rankings in any country, signaling a shift in consumer perceptions and market dynamics. Tesla continued to expand its lineup with the introduction of the Model X SUV in 2015 and the more affordable Model 3 sedan in 2017. The Model 3, in particular, marked a turning point in the mass adoption of electric vehicles. Crucial in making electric vehicles accessible to a broader audience, Tesla's Model 3 became the best-selling electric car globally by 2014. That same year, Tesla introduced its autopilot system, a suite of advanced driver assistance features. Elon Musk's vision went beyond just partial automation. He frequently talked about achieving full self-driving capabilities. Despite ambitious timelines, fully autonomous driving proved to be a complex challenge, with Tesla facing both technical issues and regulatory scrutiny. Tesla's rapid rise wasn't without obstacles. The company faced production delays, legal battles, and financial pressures. Musk's leadership style and public statements sometimes drew criticism and regulatory attention. However, Tesla's influence reached beyond its vehicles. The company's focus on renewable energy solutions, like solar panels and energy storage products, aligned with global sustainability trends. Tesla's success also pushed traditional automakers to speed up their own electric vehicle efforts, increasing competition in the EV market. As the story of electric vehicles unfolds, Elon Musk's influence remains a central theme. The battery dilemma. As the automotive industry races toward an electric future, excitement around electric vehicles, EVs, is tempered by the significant challenges of battery production. While EVs promise reduced tailpipe emissions, the environmental and logistical complexities of battery manufacturing create a multifaceted dilemma. Lithium-ion batteries, the backbone of most EVs, require the extraction of critical minerals such as lithium, cobalt, and nickel. Mining these materials is resource-intensive and often harmful to the environment. For example, lithium extraction in South America's Lithium Triangle, Chile, Bolivia, and Argentina, has led to significant water depletion in arid regions, affecting local ecosystems and communities. Similarly, cobalt mining in the Democratic Republic of Congo has been linked to soil and water contamination, as well as human rights issues. Beyond mining, the battery manufacturing process itself is energy-intensive, resulting in considerable greenhouse gas emissions. Studies suggest that producing just one EV battery can emit up to 4 tons of CO2, requiring years of vehicle operation to offset this initial carbon footprint. Additionally, the global supply chain for battery materials often involves extensive transportation, further increasing emissions. The finite availability of key minerals also poses a significant challenge. As EV adoption grows, the demand for lithium, cobalt, and nickel is expected to outpace supply, leading to resource shortages and price increases. This issue is further complicated by geopolitical factors, as much of these minerals come from politically unstable regions. For instance, over 60% of the world's cobalt supply is sourced from the Democratic Republic of Congo, a country facing political instability and ethical mining concerns. The environmental impact of EV batteries. Addressing the environmental impact of EV batteries goes beyond production. It also includes end-of-life management. Currently, only about 5% of lithium-ion batteries are recycled due to technological and economic challenges. Improper disposal can lead to soil and water contamination. However, efficient recycling could mitigate environmental harm and reduce resource scarcity by recovering valuable materials. Companies like Nissan and Volkswagen are investing in battery recycling initiatives, but widespread implementation remains limited. The transition to EVs also requires significant investments in charging infrastructure and poses challenges for existing power grids in many areas. In some regions, electrical grids may struggle to handle the increased demand from widespread EV adoption. Moreover, if the electricity used to charge EVs comes from fossil fuels, the environmental benefits of reduced tailpipe emissions may be negated. Therefore, the success of EVs in reducing overall emissions depends on the decarbonization of the energy sector. Toyota's approach to electrification. Recognizing these challenges, Toyota has adopted a more cautious approach to electrification. The company has focused on hybrid technology and is investing in alternative solutions, such as hydrogen fuel cells. Toyota's strategy reflects the belief that a diversified approach, including hybrids and hydrogen-powered vehicles, may be more practical and environmentally responsible in the short to medium term. This approach seeks to balance consumer needs, environmental impact, and resource constraints. As the automotive industry grapples with battery-related challenges, Toyota's engineers have been exploring innovative solutions beyond traditional paradigms. Their research has led to groundbreaking developments that could revolutionize the future of transportation by seamlessly integrating the benefits of both internal combustion and electric power. Toyota's commitment to innovation continues as it strives to balance performance, sustainability, and environmental responsibility. Engineering excellence. Toyota is leading the way with a new generation of internal combustion engines that aim to redefine industry standards and challenge the prevailing shift toward electric vehicles. In 2024, Toyota, in collaboration with Subaru and Mazda, announced the development of advanced internal combustion engines designed to integrate seamlessly with hybrid systems and operate on carbon-neutral fuels. These engines are more compact than previous models, allowing for lower hoods and improved aerodynamics, which ultimately enhances fuel efficiency. The latest innovations in Toyota's engine technology focus on achieving higher thermal efficiency and versatility in fuel usage. These new engines are designed to run on various fuel types, including gasoline, synthetic e-fuels, biodiesel, and hydrogen. This flexibility reduces reliance on fossil fuels and aligns with global efforts to minimize carbon emissions. A major engineering breakthrough in these new engines is the reduction of piston stroke, which leads to a more compact design. Although this modification posed significant challenges, it ultimately resulted in engines that are 10 to 20% smaller than their predecessors. The smaller size allows for lower vehicle front ends, optimizing airflow and improving fuel efficiency. To compensate for any potential torque loss due to the shorter stroke, electric motors are integrated into the engines, providing instant power and ensuring that performance isn't compromised. One of the most revolutionary aspects of Toyota's new engine technology is its ability to use hydrogen as a fuel source. Unlike traditional fuel cell vehicles that convert hydrogen into electricity, Toyota's approach involves directly combusting hydrogen within the engine. This method uses existing internal combustion engine ICE technology while producing zero carbon emissions, with water vapor as the only byproduct. Toyota has accelerated the development of hydrogen combustion engines through its participation in motorsports. By deploying hydrogen-powered vehicles in racing scenarios, Toyota has been able to test and refine the technology under extreme conditions, gaining valuable insights that will inform consumer-ready models. The company's commitment to advancing ICE technology is further demonstrated by strategic partnerships. In 2024, Toyota, Subaru, and Mazda announced a joint initiative to develop new engines optimized for hybrid systems and compatible with carbon-neutral fuels. This collaboration aims to refine engine technologies through shared expertise and friendly competition, ensuring the resulting powertrains meet consumer needs while adhering to environmental standards. Looking ahead, Toyota plans to integrate these advanced engines into its vehicle lineup by 2027. The focus will be on hybrid applications, where the new ICE units will work alongside electric motors to deliver enhanced performance and efficiency. Toyota's development of efficient, versatile internal combustion engines presents a compelling alternative to the all-electric paradigm that has dominated recent automotive discussions. By offering engines capable of using carbon-neutral fuels while delivering exceptional performance, Toyota challenges the idea that EVs are the only solution for sustainable transportation. This innovation not only provides consumers with more choices, but also addresses some of the challenges associated with EVs, such as battery production impacts and charging infrastructure issues. As Toyota prepares to introduce these engines to the market, The automotive industry may experience a renewed appreciation for the potential of internal combustion technology in achieving environmental goals. The perfect storm. By 2023, the automotive industry began to face a perfect storm of challenges that exposed the limitations of an all-electric future. EV sales growth showed signs of slowing in key markets, while charging infrastructure struggled to keep pace with the rising number of electric vehicles. Concerns about the capacity of electrical grids became more pronounced, and the fluctuating prices of raw materials essential for battery production began to raise alarms. Additionally, the environmental impact of disposing of aging EV batteries became a growing concern. Despite the initial surge in EV adoption, recent data revealed a deceleration in sales growth. Contributing factors to this slowdown included the high cost of EVs compared to traditional vehicles, limited driving range, and inadequate charging infrastructure in many regions. As a result, consumers remained hesitant to fully embrace electric mobility, leading to lower than expected sales figures. For example, in the United States, electric vehicles accounted for only 18% of sales between January and October of 2024, falling short of the 22% target. By regulatory mandates, the rapid increase in EV adoption, prompted by regulatory mandates, exposed significant gaps in charging infrastructure. Many regions lack sufficient charging stations, leading to long wait times and inconvenience for EV owners. Moreover, the existing electrical grids in several areas were not equipped to handle the added demand from widespread EV charging, raising concerns about grid stability and the potential for increased energy costs. The production of lithium-ion batteries, which power most EVs, relies heavily on raw materials like lithium, cobalt, and nickel. The prices of these materials have been highly volatile, driven by supply chain disruptions and geopolitical tensions. Additionally, the environmental impact of mining these materials and the challenges of recycling used batteries have raised questions about the overall sustainability of EVs. In response to these challenges, several traditional automakers began reassessing their aggressive all-electric strategies. Companies like Ford recognized that hybrid vehicles might play a more significant role in the near future than initially anticipated. Amid these industry-wide challenges, Toyota's more cautious approach to full electrification appeared to be the smarter path. The company continued to invest heavily in hybrid technology and alternative solutions, such as hydrogen fuel cells, positioning itself with a balanced portfolio of vehicles that cater to diverse consumer needs and regional infrastructure capabilities. This strategy not only mitigated the risks associated with an all-electric approach, but also aligned with global efforts to reduce carbon emissions through various pathways. As the automotive industry wrestles with these complexities, Toyota appears to be preparing to reveal an innovation that could challenge existing assumptions about the future of transportation. This breakthrough promises to combine the best of internal combustion and electric power, offering a compelling alternative in the quest for sustainable mobility. The game-changing visit. In late 2024, something extraordinary took place behind closed doors. Elon Musk, the face of the electric vehicle revolution, made an unexpected visit to Toyota's headquarters in Japan. While meetings between automotive executives aren't unusual, this visit was different due to its high level of secrecy and the events that followed. According to sources familiar with the matter, Toyota's CEO, Koji Sato, personally invited Elon Musk to review their latest technological developments. This unusual move sparked speculation across the industry. Why would Toyota share their closely guarded secrets with a competitor? The meeting lasted over 6 hours, during which Elon was granted access to Toyota's most advanced research facility, where their next-generation engine technology was being developed. What happened inside that facility remains largely confidential, but the effects were immediately noticeable. Several engineers who worked closely with Elon reported a significant change in his demeanor upon returning. The billionaire appeared unusually contemplative. When asked about the visit, Musk simply said, "Toyota's new engine will destroy the entire EV industry." This statement came from a man who had dedicated his career to making electric vehicles mainstream, sending shockwaves through the industry. So what did he see during that visit? While specific details are still under wraps, industry experts believe Toyota has achieved something previously thought impossible: an internal combustion engine that combines extraordinary efficiency with near-zero emissions. This system reportedly integrates advanced hydrogen combustion technology with a groundbreaking hybrid system that requires minimal rare earth materials. The potential implications are massive. Such an engine would offer the convenience and quick refueling of traditional vehicles while matching or even exceeding the environmental benefits of electric vehicles. More importantly, it would bypass many of the challenges hindering mass EV adoption, issues like grid capacity, charging infrastructure limitations, and the environmental impact of battery production. When asked about the specifics during a recent Tesla earnings call, Elon Musk's response was uncharacteristically reserved. "I made my decision to respect Toyota's wishes and not reveal any technical details to the public," he said. "What I can say is that they've achieved something remarkable, something that's made me rethink the future of transportation. Tesla will have to work much harder to create something even better." This comment from Elon speaks volumes. It suggests that Toyota's innovation is a fundamental breakthrough with the potential to reshape the entire automotive industry. Industry analysts even speculate that Toyota's new engine technology could challenge the very notion of what sustainable transportation looks like. These new technologies could start appearing in production vehicles as soon as 2026. Toyota has already filed several patents for advanced combustion systems and hybrid powertrains, though the specifics are still tightly under wraps. What's clear is that this development has sparked a major rethinking of the automotive industry's future. The idea that battery electric vehicles will completely replace internal combustion engines is being challenged. Instead, we might be entering a time where multiple technologies work alongside each other, each catering to different needs and markets. What do you think the future holds after hearing all of this? Share your thoughts in the comments.